Solving a system of equations by elimination. When solving by elimination, there are two big ideas. The first is to match the coefficient of either your x or y, and then either add or subtract to eliminate that variable. So again, 5 steps. Simplify and stack if necessary. Match the coefficient, the x's or the y's. Eliminate by adding or subtracting. Solve for the variable, and then solve for the other. So I have 4 examples. Looking at the first one, I can see that the y's have the same coefficient. So the matching portion of the task is done for us. It doesn't matter that they're positive and negative, only that the number is the same. So in this case, I'm going to label it 1 and 2. And then if I'm trying to eliminate the y's, I'm going to add them vertically. So I'm going to take my 3x and my 5x, add those together, and that gets me 8x. If I add positive 2y to negative 2y, I will get 0y. And if vertically I add the 19 and the 5, I will get 24. We normally don't write the 0y, but I wanted to show that the y's are eliminated. And now you're down to one variable, 8x equals 24, and you can solve for one variable by dividing both sides by 8. The 8's cancel and become 1, and x now equals 3. So to solve for the other variable, you can use whichever equation you want. In my first example, I'll show you both equations and how they get to the same answer. So if I substitute into equation number 1, x equals 3, it becomes 3 times 3 plus 2y equals 19. So 9 plus 2y is 19. Take the 9 across, it becomes negative. 2y equals 10. Divide both sides by 2, and y equals 5. I can do exactly the same thing, get the same value using equation number 2. So 5, x is 3, minus 2y equals 5. 15 minus 2y equals 5. Negative 2y equals 5 minus 15. And I forgot my y. There it is. So negative 2y equals negative 10. Divide both sides by negative 2. The 2's cancel and become 1, and y again equals positive 5. So whichever equation you choose to find your other variable, you will get to the same place. So in this case, our point of intersection is 3 and then 5. So we're going to check the coordinate 3, 5. Back to our original equations. When you check, it's left side, right side, no equal signs, because you are checking to see if you've done it correctly. So I'll separate this out and I'll do them side by each, and I'll set them up at the same time. So subbing in 3 times 3 plus 2 times 5, 5 times 3 minus 2 times 5. Looking at the left-hand side, this becomes 9 plus 10, and you can see that my left side is 19 and my right side is 19. So these two values are the same. On to my second equation, 15 minus 10, and that's going to equal 5, and that's what I started with on the other side. So again, my left side equals my right side. So I've checked both equations successfully. So therefore, the POI, point of intersection, is, I have to check, 3, 5. And now to my second example. You can see in the second example that I do not have a common coefficient or a common number in front of either x or y. I'm going to match my coefficients, which is the first step, so the process is to match and then eliminate. And I'm going to choose x to match. 3 times 4 is 12, so if I multiply the top by 4 and the bottom by 3, I'll be able to match my x's. And the reason you can scale up or down is that you're not changing the line, you're just changing what the equation looks like. So in equation number 1, if you scale it up by 4, it becomes 12x plus 8y equals 8. And equation number 2, you're going to get 12x plus 15y equals 36. And now I've successfully matched the variables in front of my x's. They're now both the same. In this case, they're both positive. So to get to 0, I'm going to subtract. So 12 minus 12 is 0. So I successfully eliminated the x's. 8 minus 15 is negative 7. And 8 minus 36 is negative 28. So as you get good at this, you wouldn't write 0x. You would simply write negative 7y equals negative 28. And to get y by itself, divide both sides by the number in front of your variable. The 7's cancel out and become 1. And you get y equals 4. Now you can use any equation you want to find the other variable. I'm just going to choose equation number 1. I'll do it off to the right here. So it becomes 3x plus 2, y is 4, and that equals 2. So 3x plus 8 equals 2. 3x equals 2 minus 8. 3x equals negative 6. Divide both sides by 3. And x equals negative 2. Therefore, your POI is alphabetical x and then y. So I'm now going to check that. Now you notice that I manipulated both equations, but when you do a formal check, you check the original equations. So again, I like to write the point of intersection close to where I'm checking. You write your equation with no equal signs separated out. And my second equation is 4x plus 5y and 12 on the other side. And again, I like to set it up first and then calculate second. So I'm going to sub all my variables in while it's fresh in my brain and I can see it, so I don't make a silly mistake as I go. It's all set up. Now I'll do the math. So 3 times negative 2, negative 6, plus 8, that is 2. And you can see the left side equals the right side. This becomes negative 8 plus 20 on the other side, which becomes 12. And again, you can see that the left side equals the right side. So you can confirm that the POI is indeed negative 2, positive 4. So this is the case where you have to scale up both equations. You don't have to scale up both. You can scale up one or the other, or neither, just depending on the case. My third example of 4 has decimals. So I'm going to label them, again, 1 and 2. And the first thing I'm going to do is clear my decimals. I can see that it's consistent and I have one decimal place in each one. So I'm going to multiply both equations by 10. So now I'll get 6x minus 3y equals 2.4. And negative 4y plus 7x minus 29 equals 0. I'm going to go one step further and order them alphabetically. So I'll put the x first. So my first equation is perfect. I made a mistake up here. That should have been 24 and not 2.4. And number 2, I'm going to put my x first and then my y. And I'm going to put my 29 to the other side and make it positive. And now I've got two equations that look like they're in the same format. You can either make the x's the same or the y's the same. If you're looking at the x's, the smallest number that you can get to make them the same, 6 times 7, would be 42. So that's multiplying the top by 7 and the bottom by 6. If you look at the y's, we have a situation where 3 times 4 is 12. That's going to create smaller numbers. So that's what I'm going to go with. So I'm going to multiply the top by 4 and the bottom by 3. So equation number 1 becomes 24x minus 12y equals 96. My second equation, multiplying through by 3, becomes 21x minus 12y equals 3 times 9 is 27, 3 times 20 is 60, so that would be 87. Now I have two negative values, so I'm going to subtract one from the other. 24 minus 21 is 3x. And this time I know that the y's cancel out. Negative 12 minus negative 12 is 0. And 96 minus 87 is 9. And I can see quite quickly that x is going to equal 3. You can use any equation you want to find your other variable. So I'm looking at my possibilities here, and my possibilities are any equation from here upwards. And I think I'll choose this one here. So equation number 1 is 6 times x, which is 3, minus 3y equals 24, which gives me 18. And so I can switch my 24, pull it to the left, make it negative, and push my 3y and make it positive on the other side. I'll get negative 6 equals 3y. Divide both sides by 3. And y equals negative 2. That gives me a POI of 3, negative t. 3, negative 2 is what I'm going to write under my check. And then I must check my original equations. So I'm going to write those out carefully. And I'm going to separate them out so that I have left side and right side. So negative 0.4 y plus 0.7 x minus 2.9 and 0. And now I'm going to sub in, again, quite carefully, putting 3 where x is, and negative 2 where y is. I like to fill both sides in first as I go and then solve. Oh, and I just made a mistake. So looking at this equation, it's 0.4 y. Easiest thing in the world to do is not to be careful. So it's y, which is negative 2, plus 0.7x, which is 3, minus 2.9. Just checking it over carefully. It looks like I've got it set up correctly. And now I'll do some mathematics and calculations. So this becomes 1.8 minus 0.3, except it's not minus because I have a double negative, so it's actually a plus. So carefully do your addition, multiplication. That becomes 2.4. And I have success. Left side equals right side. Over to the next equation. A negative times a negative is a positive, so it's 0.8. I have two positives, and this will be 2.1. Bring down your negative 2.9. So 2.9 minus 2.9 gives us 0. And so success again, left side equals right side. And now I've confirmed that the POI is indeed 3, negative 2. And now my last example, which are a pair of fraction equations. So just like with decimals, we're going to clear our fractions away, just like we cleared our decimals away. In the first equation, I can see that the common denominator would be 8, so I'm going to multiply both terms on the left-hand side by 8, as well as the term on the right-hand side of the equation by 8. I often find that students forget to do the right-hand side. 8 divided by 2 is 4, and 8 divided by 8 becomes 1. So I'm left with 4x plus y equals 32. My second equation, the common denominator between 2 and 3 is 6. Multiply each term by 6. Again, don't forget the right-hand side of your equation. 6 divided by 3 is 2. 6 divided by 2 is 3. This leaves you with 2x minus 3y equals negative 12. I like to rewrite my equations just to keep things tidy. So 4x plus y equals 32. And 2x minus 3y equals negative 12. I could certainly solve by substitution here, but let's carry on with the elimination method and match one of our coefficients. I could match either the x or the y. I think I'll match the x this time by simply multiplying the bottom equation by 2. So again, I'll write the first equation. And my second equation, I'm scaling up. So I'm going to multiply each term by 2. And looking at it, the 4's are now the same with 4x and 4x. To get rid of it, I need to subtract. So the x's are now gone. Y minus negative 6y is positive 7y. So y minus negative 6y is positive 7y. There's no need to write the positive sign. I was just trying to show you the method to get that particular value. So 7y now equals 32 minus negative 24, which is positive 56. Divide both sides by 7, and you get y equals 8. You can use any equation you want to find out what x is. I'm going to use that equation there. So in this case, it becomes 4x plus y, which is 8, equals 32. 4x equals 32 minus 8. 4x equals 24. Hopefully you can see it's 6, but let's divide properly here by 4. Cancels out and becomes 1, and x is indeed 6. So the POI is alphabetically 6 and 8. And now let's check 6 and 8 to see if we've done it correctly. So I'm going to check 6 and 8 into the original equations. So I'm going to write them out. X over 2 plus y over 8, and that equals 4. Again with the check, no equal signs. Second equation is x over 3 minus y over 2, and on the other side will be negative 2. Let's sub in carefully our 6 and 8. So it becomes 6 over 2 plus 8 over 8. And the second equation, it becomes 6 over 3 minus 8 over 2. Now to do the math, 6 over 2 is 3, 8 over 8 is 1, and we get the left side equaling the right side. Second equation, 6 over 3 is 2, 8 over 2 is 4, 2 minus 4 is negative 2, and you get left side equals right side. And I consistently forget to put my equal signs in. So now we've got a therefore statement. The POI is 6 and 8. Thanks for listening. Bye for now.